So, สวัสดีค่ะ Welcome to Voice of the Nation. Today you're with me, Nina Nirashamalisak-Lamir. And today we are going to talk about health and wellness and focus on one of the important organs in our body, which are our eyes. Did you know that in this world there are about over 10 million people are waiting for their cornea to be donated and to be implanted? So wouldn't it be nice if we don't need to wait? And we don't need to be in this waiting list. And in Thailand, there is a group of startup or researcher has come up with a tissue engineered cornea. So we don't need to be on the waiting list anymore. So let's find out together with here in our program. Please welcome Dr. Khao Thonsomboon from Biotech Nasta Researcher Microarray Research Team and Relife Co Limited CEO.
Hello สวัสดีครับคุณนีน่า
Hello สวัสดีค่ะ How are you?
I'm great, thank you.
First of all, welcome to Voice of the Nations, and thank you for being here. So, could you please projects that we heard about you have come up with the tissue engineered cornea? What is this?
Actually, the project of tissue engineer, it started about 10 years ago when I did my PhD back in the UK, because it's my passion since my high school to develop medical innovation to improve quality of life of people. And that time, my dad got cataract, which is a symptom that he couldn't see things properly due to the opaqueness of the ocular lens. So that time, I realized that our vision is so important, very essential for living. So I did research more on eyes, and I found out that cornea is one of the amazing tissue that many people look over. And there was a huge gap between number of people who are waiting for corneal transplantation and the supply. Like you said, there are about 10 million people waiting for donors, but only 15% are lucky enough to get the donor.
Who gets it?
Yes.
And then the rest will have to live in that life conditions, cannot see properly or cannot see clearly.
Exactly. Like in Thailand, patients may have to wait about 2 or 3 years to get
2 or 3 years to get that.
That's really painful. So 10 years ago, that's why I decided to do my PhD in tissue engineered cornea, and hoping that this new material can be a solution for this problem.
Do you think why is this project is so important?
Well, 10 million people having difficulty in life, that's big enough to jump in and try to solve this problem. And this problem occurred 10 years, 20 years ago, and it's still a global problem today. That means someone needs to jump in and help people.
There's this problems actually not many people has come up or think about that. From the past, has it been any research about that to have come up with probably a tissue that can replace the real cornea? Has there been any research about that before?
Actually, before the idea of tissue engineered cornea, there's been something called plastic cornea or artificial cornea. So someone has already developed a cornea-like structure, but they are made of plastic. And I think it's been used for 30 years now, but it's not popular among surgeons because these plastic corneas, they are not part of the body. They're made of materials that far different from the real tissue in the body. So when surgeons implanted these materials into patients' eyes, it caused many post-operative problems afterwards. So that's why tissue engineering, that I'm going to explain to you soon, what are they?
What make it different? What make it
Okay.
different from the what do you call plastic cornea as
Plastic
well?
cornea.
Mm-hmm.
Okay. The concept of these two solutions are totally different. Plastic
Right.
cornea is we are trying to replace the bad or diseased tissue with
Mm-hmm.
a device that are not degradable, and made of something, made of man-made material like metal, plastic, ceramics. So
It's not
these
natural.
is not natural. Okay,
Mm-hmm.
that's the first thing.
Mm-hmm.
But tissue engineering is the concept in which it is a process to um, regenerate new tissue from stem cells, because we all
From
know from stem cells,
okay.
we all know that our tissues, our organs are made of cells, right?
Cells.
So we are trying to tell cells, to grow cells, and tell them to develop into a new tissue that we want, and that gonna give patients a whole new tissue. It's like fresh new tissue, like when we were young. And this solution will stay with them forever until they die. So that the difference between the two.
So how does it work?
Okay.
How does it work, or has it been any experimented? What are the stages right now?
Okay, let me explain how does it work first. Okay, you know now that we would like to grow cells from single cell into thousands, millions of cells, and they form into a tissue, in this case, cornea. What we do is I have to grow cells in an engineered 3D structure that
So
looks like. Mhm,
okay, so this one is called tissue engineer cornea,
yes,
and this is the process that you're telling me right now that how it makes.
exactly.
Okay,
Okay,
please
so
go ahead.
I am an engineer. Okay,
Right.
instead of building a house for you, for human, I'm building a house for cells. Okay, and I call
Okay.
this house scaffold. Scaffold is a 3D structure that has to look like and function like the tissue I want to make. Okay, in this case, I have to make something that looks like cornea, can function like cornea, but they're made of natural material. Okay, and then I'm going to put my cells into this house. I'm going to call it a house. Okay, and then once cells are in the house, they will start growing, increasing in numbers. Okay, and the house with the cells embedded, the whole thing is called tissue engineer cornea. Okay. Okay. Once we've got this thing in the lab, we will transfer it into the body, into patient's eye. Okay. Once it is in the patient, what happens is the cells will slowly eat the house, degrade the house,
The
and
natural cells.
the cells we put in the house
Right.
will slowly degrade the
Right.
house I made,
Mm-hmm.
and then they will create the new house that look exactly the same and can function like natural tissue by themselves in the body. So finally, patients will get the final tissue that is freshly made from cells. That's the idea.
Okay.
So the design of the house is very important, because not only the house will protect the cells, the house will act like a blueprint when you build a real house, and give cell information what kind of house you have to build yourselves in the future, so you will end up with the correct tissue that we want.
So for now, what are the stages of your research
We are in the stage of testing safety in animals.
in animals?
In animals.
Mm-hmm.
So we work closely in collaboration with a medical team from Chulalongkorn Hospital to test the safety of the materials.
So far, how effective it is?
It's been good, actually. We got pretty good, very positive results in the lab. And hopefully we hope that we're going to get positive results in animal. So we can proceed to the next step, which is a clinical trial in human.
What is the timeline that you think this research or this project will be finalized and will finally be approved by the
The regulatory body.
Yes.
And hopefully in 5 years.
Hopefully in 5 years.
Yeah,
So in 5 years' time, could you please tell me the plans after it's been approved, that where it goes, and would it go into the hospitals, or would it go into how does it work?
Okay, so let's say our products have been approved. Okay, so the situation is when patients come into the hospital and they need corneal transplantation. Surgeon has to prescribe, tell us that, okay, we want tissue engineered cornea. So what happens is we will build a house that is specific to each patient.
To the patients.
To the patient. And then we will send this house to the hospital. Okay? The surgeon will then use this tissue engineered cornea as if it is a donor tissue, using the same procedure that they do with the donor tissue. So they will cut the tissue and then put into patient's eye and then stitch the tissue engineer into the eyes. Exactly the same process.
Is it exactly the same process as when people doing their LASIK?
No, totally different. Totally different. The process of corneal transplantation is surgeon has to remove the central part of your cornea out and then put exactly the same size donor tissue in, or in this case, tissue engineered cornea in, and then they use something to seal it, stitch the tissue engineer with the surrounding tissue. And that's the process.
So that means that the tissue engineered cornea will be almost as the same as the real one that we have in there. That will blend.
Exactly.
Oh, how long does it last? A lifetime?
In theoretically, lifetime.
Lifetime. And well, let's say if it's approved, and for example, there's a patient, and then they make a request and send you the request for you to make the house. How long do they have to wait for that, for their house, the new house, to be ready?
I determined to make it less than a week, or at least maximum is 2 weeks.
Less than a week. So that means that after, if this project is is approved, you will actually help a lot of, or maybe help to improve a lot of patients' life standard.
Yes, that's our wish and our hope, big hope. That we're going to return a new world to many people.
A new world, yes. We're going to see it clearly. But who benefits from this?
Apart from patients.
But I would like to focus for this one, patients, what categories of the patients? Because we have a lot of patients with the disability, blindness, different type of disabilities, yes.
Yeah, different type of blindness. Okay, so those who gain benefit is those who suffer from corneal blindness. And even in corneal blindness, there are different levels of blindness. It could be total blindness, partial blindness. So anyone who want to fix the cloudiness of their cornea, will get benefit from this.
Mm.
And apart from patients, this tissue engineered cornea can be used as a testing model for cosmetic products as well. Cosmetic products.
Like contact lenses?
Yes, any products related to cornea, related to eyes, have to test safety using animal eyes. So we're gonna save lives of plenty of animals too, so they don't have to suffer from bad chemicals. So that's another benefit.
What about the group of people who are suffering from that we call กระจกตาบาง? What was that?
Okay.
What's
Yes,
that called in English?
keratoconus, the thinning. Keratoconus is a symptom where your cornea gets thinner and thinner progressively, and one side I can tell that you might suffer from this keratoconus is you got astigmatism or side.
Yeah. That's right.
And at some point you're gonna get very painful and you cannot see things clearly. And at the end you have to replace your cornea with donor tissue as well. So any symptoms, any diseases that require corneal replacement and you need donor tissue will get benefit from tissue engineered cornea.
Okay. I would like to ask, how is the process? Is it dangerous? Like, for example, if I was a patient, I would like to get this implant. Is it dangerous? How scary it is? Like how patients would be very worried when they have something new and the new technology, especially transplanting our own body. Could you please elaborate this a little bit more?
Of course, it is. When we implement new technology, a new concept, it is scary. It is dangerous. But I can make sure before we use this technology to patients, we would test hundreds, thousands of times in the lab, in the clinical trial. That's why we need long time to do clinical trial, 3 to 5 years, to make sure that this process is safe and will not cause any adverse effects to the patients. And if it's not safe, regulatory bodies wouldn't grant us approve us to use this new product or new procedure in clinics. So patients can be confident that once it's been approved, it's going to be safe. Otherwise, I won't let my product to be in your eyes because I want to help you, not to hurt you.
Dr. Kao, could you please talk about this project? You have already talked about how it has started, why you start this project, but I would like to talk about this project in terms of you are a researcher. You are what should I call it? A startup for this one?
Yep.
And in cooperations with your research project, is it in cooperations with any organizations that actually help you to do further research about these projects?
Okay, the first collaborator is medical team from Chulalongkorn Hospital.
All Thai.
All Thai. Team.
Okay.
And we've got business partner, which is a CEO of another startup company called Fruta Biomed, which is a biomaterials startup company in Thailand. CEO is Thai. It's a Thai organization, and they support us 100 million baht to prepare
to do this project and research.
To do this project, granting the first money, seed money to prepare for clinical trial in humans. Okay, so with this money, with this budget, I need to construct a new plant with GMP standard, because before I have to explain that currently I made my tissue engineered cornea in the lab, which is acceptable to be used in animals, but I cannot use this setting like in the lab to produce a product and be tested in human. because it's not safe. There's no quality check. Okay, so I need a plant to produce tissue engineer in a quality control way, and need lots of budget. So luckily I got this huge amount of budget, 100 million baht. So
Wow.
that
That's a
that
big
seems
project.
that seems a lot, but actually, making a clean room for growing cells, it cost, millions, 100 millions baht. That's why we need lots of budget.
When talking about cells, what are the cells?
The stem cell.
The stem
Actually,
cells.
what are stem cells? Okay, stem
From
cells.
where?
From where? Okay, by definition, stem cells are young and fresh cells that can grow continuously, can expand continuously. And the first definition, they are young, they can grow, it can expand, increase numbers continuously. They have no specific function. They are like young kids, they don't know what they want to do. Okay. And the third function is they can transform into any adult cells. Like they can become heart, they can become bone, they can become cartilage, they can become eyes, they can become cornea. Okay, that's the definition of stem cells. So where are they from? Ideally, they should be from patients, because if it's your cells, there will be no risk for immune rejection. Okay,
Right.
that's one possible source. Second possible source is in the R&D world, we are trying to develop a universal stem cells that can be used in any patients,
Anybody.
without causing any negative effects.
Right.
Okay.
If this project is approved, what are the costs?
Okay. Good question. Very good question. um, we are trying to make it affordable for everyone. Otherwise,
Right.
it will be useless to develop new technology that no one can buy. Okay. So in Thailand, the current cost that is supported by Sopao to do corneal transplantation is 50,000 baht. 50,000 baht. Okay. So that's the benchmark that we are trying to meet. Okay. But if our production cost and everything, when we calculate it, we cannot sell at 50,000 baht, we
Right.
need to find a business model to grab money from those who can pay, like from somewhere
The
else,
hospitals.
from different countries or from big companies to buy our products, and they do CSR for the
The
public,
patient. Okay.
the patients. Okay, so we are trying different ways, different approaches to make it affordable, make sure that anybody who needs it can get it. Okay.
So right now is about estimations, but in the final process, you will try to make it affordable for everyone. So everyone will have their eyesight improve.
Exactly.
Apart from this project in the future, or even right now, do you have any other projects like this, or maybe in the future at all? Will you come up
Yes,
with any?
definitely. I would love to grow other tissues apart from cornea. And there are a few that are lining up. I'm not sure I should mention here. I can say, yeah.
No?
There are cartilage,
Oh, okay, that's good. That's good.
nerve,
Nerves. Wow.
and hair. Because all growing other tissues, they share the same principles, the same core technology. I might have to work with different kind of cells. I have to design different kind of house to suit for different tissues.
Okay, so Dr. Kyle, thank you very much for sharing the information with us today. And actually, it's been quite a pleasure to find out that Thailand has a lot of researchers that actually continuously doing the research for not just only Thai people, but if this project, for example, one of the projects, this is one of the projects that a lot of Thai researchers have are on the process right now. If this project is approved, then you're not only saving Thai lives, but you will save a lot of and improve a lot of life standards of the world's populations. So for now, thank you very much, Ka. And that's all for Voice of the Nations. And stay tuned with us from Monday to Friday from 8 to 8:30 p.m. for today. สวัสดีค่ะ ขอบคุณค่ะ Dr. Ka.
ขอบคุณครับ